Okay, we've got a big complicated part to deal with right now. This is going to be really hard to understand, but I'll explain it anyway. If it's too hard to understand, you can skip to the next lesson and you can just copy my code later, even if you don't understand how it works. So this is really complicated. Now, as I showed you before, we got the map being drawn on the screen, but just drawing it isn't enough to make the characters interact with it. So these walls aren't walls. Our player goes right through the walls. That's no good. We need to make it so it knows in the program what's a wall and what's not, and it gets stopped by it. That's going to be a lot of steps, and I'll show you the first one I'm planning right now. So this involves some hard to understand math, but let's have a look. What I'm going to do first is I'm going to print some debug information on the screen as the game runs. So here in the draw function, I'm going to type print, and I'll just show you how it works first. So print hello, it's just going to be the word hello, and we put it in quotes, and we know we did it right, it's in quotes because it turns blue. And now I choose the pixel location to print it at. So the top left corner will be 0, 0. And the color we want to print it at will be 7, because 7 on our color index, if we go 0, 1, 2, 3, 4, 5, 6, 7, that's nice, easy to see white. So we put 7 to pick the color, 0 to pick the location, and the word we want to print is hello, and it's going to be in the draw function. So let's run that. Now the word hello is in the corner. Now the reason I want to print something in the corner is because I want to print some information about what's happening. So the variable that we have in the game right now, one of the three we have right now, is player X and player Y. So let's take out the quotes and the word hello and just put in player X. And now let's run it. And now we see a number that indicates how far left or right our character has went. But we got a problem because up here we know from our tile map editor that this is tile 0, 0. We can see it written on the bottom of the screen down here. So this is tile 0, 0. This is 1, 0. Over here is 0, 3. And these are the coordinates. So when we're on screen with our character moving around, we're counting pixels, individual pixels on the screen. But in our tile map, we're counting tiles. And there's 8 pixels for every tile. So we need to figure out what tile we're on. And we need to do a little bit of math that's kind of fancy and complicated to convert our pixel position to a tile position easily. So what I'm going to do is we're printing player X. I'm going to add some info. So I'm going to call this pixel X. And then I'm going to put a colon there and a space and close the quotes because these are words we're typing here, not variables. If we're ever typing words, they got to be in quotes, and variables have to not be in quotes. And to stick the words with the variable, I put dot dot in between like that. So I got the word pixel space X colon, and then dot dot, and then the variable. So now I see my pixel X. Now I need to figure out what my tile X is going to be. So I can do that pretty easily if we know the complicated math. So I'm going to say print below that tile X, and for now I'm going to call it, I'll just put player X for now. We're going to do the math inside the print, and we're going to make a better function for it later, but I want to explain the complicated problem we have first. And since I need to print that, if I run it now, they're right on top of each other, the words tile X and print X. Can't tell what's going on. So I've got to move it down. So I'm going to give it a Y coordinate of 6 just to print it there. And that's just the position of the text. So we have pixel X and tile X. Right now they're the same because our program is not calculating the tile X correctly. So if there are 8 pixels in every tile, we need to divide the pixel value by 8 to get the true tile value. So instead of printing just player X, let's print player X divided by 8. We should get close to what we want. Now look at this. That doesn't make sense either. That's not the actual tile position. So we need to do something. Oh, hold on. I did modulus instead. Let's do divided by 8. And when you're programming, division is done by a slash like that. So here is our actual tile X. So here's tile 0. That makes sense. Here's tile 1. That makes sense. But you'll notice that we have up in our tile X value, we have remainders. We have 0.25, 0.75. That's actually not helping us at all. So we need to take those remainders and we need to get rid of them somehow. So what we need to do, and this is where it gets complicated, is we need to change this formula to be player X negative player X modulus, which is the percent sign, 8. So that'll be whatever the remainder is when divided by 8, because that's what modulus does. It's like division remainders. Now we need to put brackets around this. I know it's complicated, but bear with me. And now we divide that by 8. So we're taking away the remainder. Now let's hope I did this right. Nope. So, oh, I called it player instead of player X. That was my mistake. So we can see here, it shows me the error, it shows me my code, and it says attempt to perform arithmetic on global player, a nil value. That's because there is no variable named player, there's only player X. So let's see if I got it right this time. There we go. So I know the math was really complicated, but now we have a variable for pixel X, which shows us what X pixel we're at, and we have a variable for tile X. So this is he's at 0 right now, or specifically his top left corner, because that's where his sprite gets drawn from. So his top left corner, his pixel X is 1, -1 if we go off screen, but now we can get the tile values. And now we know what tile we're at in addition to what pixel we're at. And that information is going to be great to have when we start writing some code so we can check if these are walls or not. So let's just make our debug a little better for now. We're probably going to erase this later, or we can move it to a debug function. In fact, let's do that. We'll move it to a debug function. So I'm going to take it, so first of all, I'm going to make it so it shows us our Y as well, so pixel Y, and that'll be at, make sure we change both the text that we're printing and the variable, and that'll be at 6. Then we're going to do tile X and tile Y. Okay, and player X, player Y. And I gotta move these down a bit. So this one will go another 6 down to 12. This one will go another 6 down to 18. And now we have both pixel position and tile position being calculated, which is great. But that shouldn't be kicking around in our draw command, in our draw function. It's not a very smart place for it. So let's make our own function. We're going to call this one function debug. And I think it's the first time we made our own function that's not one of the main 3 functions of Pico 8. The main 3 functions of Pico 8 always start with an underscore because those are essential. The ones we make ourselves by choice don't have an underscore. So we just call it function debug. Now let's copy all this debug stuff. Let's go Control X to get rid of it and Control V to paste it up here. And now we have our debug moved to the debug function. So now if I run it, the debug is gone unless I put a call my function in the draw function. So if I type debug down here, since that function is made, and I'll put the opening and closing parentheses there, now I call whatever's happening in the debug function. So now it's back. So if I ever want my debug information, to go away, I can put 2 dashes there to turn that line into a comment, and then the program won't run it. And if I want my debug information back for if I'm running a test or trying to make sure it's working, I can take away the comment dashes and it'll come back. Alright, so we learned how to make a function, we learned how to print some details on screen, and we learned how to calculate the difference between tile X and pixel X. So we can take pixel X and get tile X from it. So let's just remind you what that math is. It is this function right here. So you have to be sure to get these brackets in here correctly, but these parentheses incorrectly. But these parentheses are player X negative player X in parentheses again, modulus 8. That gets rid of, that sort of makes the remainder. And then we divide that remainder by 8. So I know it's complicated. You don't need to understand how it works. You just need to be able to write that code to do the conversion from pixel location to tile location. So now that we can figure out a tile location, we can write some smarter code to determine if our character is allowed to go on top of the tile. Because right now, he's able to go through. We have to check and see if it's solid, and we're going to learn a few new things about tiles when we do. Alright, stay tuned.